All right, so in this question, we are giving 9 lens prices, all right? And we want to figure out at the level of 0.1 of significance whether the lens is different than 6.5 dials, all right? So now, the last statement is actually the mean is different than 6.5, and this one would be nothing else than H1 because it's different, right? And this is also going to be the claim. So here mu1 is going to be different, and here is going to be 6.5, and this one is going to be equals and 6.5 as well, right? We check it, we're good. Now they're asking you for the critical value, all right? So now, in order to get the critical value, you need to refer always to the alpha, all right? So the alpha is given here, right here, which is 0.1. All right, so probably here, let me explain that we are in 2 tails mode, and the alpha is going to be split in 2. So here, this is going to be alpha over 2, which is 0.1 divided by 2, all right? And this is going to be 0.05, all right? So what we're going to do, we're going to use the table, and we can see the critical value. All right, so the table is right here, the first one, loading, and you're looking for 2 things, right? A degree of freedom. So our degree of freedom, because we have 9 data, degree be 9 minus 1, always n minus 1, all right? And this is going to be 8. And I think here is saying the upper tail area, all right? So I mean only 1 tail, right? And that's going to be 0.05. That's alpha over 2, all right? So this is only 1 tail, alpha over 2, and we say alpha over 2 is going to be 0.1 divided by 2, and this is going to be 0.05. Okay, so the value that we are looking for is 0.05 here. The 8 is over here. We can extend it, and we can see is 1.8595. all right, so this is going to be 1.8595. however, remember you are in 2 tails, so 2 tails is always going to be plus or minus, all right? And let's check it, and it's great. Okay, so now he's asking us for the test statistic, right? So for this purpose, I'm going to use the TI-84 because I think it's easier. They are only numbers, so let's plug them in. So how can we use it for the t-test, right? Okay, so let's start. First of all, you're going to go to stat, you're going to edit, and you're going to enter your data on the first column, right? So you're going to be 425, enter, 5.07, enter, and so forth, right? .42, and then 9.78. all right, enter. The last one is giving me entry number 10. That means there were 9 already. Now how I'm gonna run the test, I go to stat, I go all the way to test right now because I'm using the t-test. all right, obviously here we have less than 30, we don't know the sigma, so we have to use the t-test. So the t-test here, enter, and what we're gonna use, the data. all right, instead of stats here we're gonna use the data. So I'm gonna scroll down. Mu0, this is your statement, 80 basically. So you're gonna put it equals to 6.5. That's the value. All right, and then we're gonna scroll down the list. That's mean L1. This is where we put the data, what line. That's first column, right? L1 is called. So now the frequency, we can skip it because each one is only frequency 1. And then here we have to choose which one of the hypotheses we have. And this is the statement of H1. So H1, you can see it right here on the screen, mu different than 6.5. So mu different than mu0. Remember, mu0 is 6.5. All right. And you're all set. So you're going to go and calculate, enter. And then you get all the data that you need. So in particular here, the first value is t equals to 0.95389. That will be your t statistics. All right. So let's put it in, we round it. So it can be 0.953 and then 8, because we have the 9 after that, we're gonna put a 9, all right? Let's check it. All right, so that's good. Now, based on this, are we accepting or rejecting? So let me do the chart really fast. Here we have, all right, here we have this, the bell shape. We have the cutoffs right here and here. So this is going to be minus 1.8595, and here you're going to be 1.8595. Those are the two cutoffs. So it means if you are within this region here, you are accepting or do not reject. All right, and the rejection zone should be right here. So if you are outside, reject here and reject here, right? Okay, so what we want here, we want to figure out where this test value is going to be placed. And as you can see, the 0 is here, all right, and 0.93 gonna be just before, all right, so it's somewhere here in the middle. So this is 0.9539. So we are within the not reject, right? So we can input this data here, do not reject. If we don't reject, always we don't have enough evidence, right? Not sufficient. There is insufficient evidence. And check it. Okay, that's good. So now we are looking for the p-value, and actually here we have the p-value, and that the second one, p equals, right, 0.36806. Again, we need to round it. So 0.3681, and the calculator taking consideration is 2 tails, so it's giving you already the p-value, not the p over 2. All right, so let's check it again. All right, we're done. Now we have to choose one of these statements. Now what we did here, we did not reject, right? So the null hypothesis is true. So you're going to be, the null hypothesis is true, the A. I cannot choose the B because saying false. I cannot choose the C saying false. And the null hypothesis when it's false, again, we cannot choose this one neither. So I'm going to go with the A because it's the only one is saying the null hypothesis is true, and that's the correct one. Now for C, all right, this is coming straight from the book, and the right one is going to be the population distribution of the amount spent is normally distributed. All right, final check. and that's all. Okay, because the size is 9, do you need to concern about the shape of the population distribution when conducting the t-test? All right, and explain. We can select C because we want to figure out always that something is normally distributed, right? So it's a bell shape. So that's all what concerns us, right? And let's check it, and that's all.